This is my explanation for Chapter 11 video assignment. So the first thing it wants us to figure out is to calculate the molarity of N2 in blood that is contact with air at atmospheric pressure. So 1 atm. And the equation we're going to use for that is Henry's law. Who's Henry? I don't know. Lily? Anyways, the constant is given to you right here. And the way you figure out the pressure is you take your so 79% of like air is nitrogen. And then multiply that by 1 atm, so it's an A. Will give you the pressure that we want. And you multiply those together, and you get your solubility, which is also the molarity. That's at 1 atm. And so that is our first molarity at that atmosphere. And then it wants us to also find the molarity at 4 atm, which is easy. We just take the exact same equation that we had before, but multiply the pressure by 4, because now instead of just 1 atmosphere's worth of pressure from the nitrogen, it's 4 atmospheres worth. And that'll give us 12 times 10 to the negative 4 molarity. The next things it wants you to figure out are determining the volume of N2 that will be released from 5 liters of blood. And for that, we'll use the good old equation Perv-Nert. So the pressure, we already figured out the pressure that it'll be at 4 atmospheres. We figured that out up here. That's 3.16 times volume, which is the thing we want to figure out, equals the number of moles times an R constant. And you got to pick the right R constant, because depending on what kind of pressure you're working with, I was using atmospheres. I guess you could use whatever you want, but I'm using atmospheres. So you want to make sure you use this one because it has atmospheres in the units. But if you do pick that one, it also has Kelvin in the units. So you need to make sure your temperature is in Kelvin. So the temperature it gives us is 37 Celsius, but you need to convert that into Kelvin by adding 273.15. And once you work all that out, the volume you get is, you can see, follow along right here, 0.036 liters. I'm converting that right away to 36 milliliters, because that'll help us in the next problem. But that is one of the answers right there, is the volume of N2 released from 5 liters of blood. The next question is how many bubbles if this escape happens in the form of bubbles of 1 millimeter diameter, how many bubbles per liter of blood is this? So the equation we're going to want to be using is what we want to do is we want to figure out the volume of a single bubble. Because if we figure out the volume of each individual bubble that'll form, we can just take the volume of nitrogen that escapes and divide it by that. And that'll give you the number of bubbles. So we use the volume of a sphere equation, 4/3 times pi r cubed. It gives us the diameter as 1 millimeter. For the equation, we want to convert that into centimeters and also divide it by 2, because it wants the radius, not the diameter, for the equation. So right here, converted into centimeters, 0.05 centimeters is the radius. And then here, you get the volume of each of the bubbles. So this is the number that we want, the number that we have been trying to figure out. So take the volume of total nitrogen escaping, divide by the volume of each individual bubble, and that will give you this many bubbles. But that is not a whole number, so you need to round to a whole number, because you can't have, like a fraction of a bubble. And that's the answer to that last question.